Hi, I'm Sean Gannon, and this is Minute Math. And we got another problem here for you. We have a square and a circle, and it's kind of drawn as this. And we want to see, well, which one has the largest perimeter circumference of these two figures. So what we see here, we have a circle inside, we have a point of tangency right here. We touch at these corners right here, D points D and C. And the center circle again is inside of this square somewhere. So with just that information, can we determine which figure has the larger area? Pause this video, see if you can solve it, but like always, we're gonna dive right in and show you step by step how we solved this problem. All right, well, first thing I'm gonna do here is I'm gonna draw a new line, okay? I'm gonna draw a line connecting the point of tangency down here, straight through the circle up to the top of the square, okay? So what we have here, for doing that, draw a line here, go straight up. Let's call these points E and an F right here. Well, since this is a radius, right here, from O to F is a radius, and it's going through the point of tangency on the circle, the, the tangency of a circle theorem says that this is perpendicular, okay? And since, well, we have a rectangle going on, or square, and then now a rectangle, these are all right angles, this is also a right angle as well. Then the other theorem we have here is chords of a circle theorem. What does that tell us here? Chords of a circle theorem tells us basically that if we have a chord here and it goes perpendicular to a line from the radius, right? Perpendicular to the line from the radius, that this chord is cut directly in half. So this chord DE, or chord DC, can be broken up to be DE is equal to EC right there. So since these two are, well, equal, the lengths are equal right here, let's give them a variable value so we can work through this problem. Let's call them variable A. That length, DE, or EC, is both equal to the length A. With that, we have, note, our radius is OF, so we can put note of that. OF is equal to our radius. And actually, if A plus A is length of DC, the side length of our square here, we can write as, well, 2A. Right? And 2A up here. All right. Well, with that, I also, well, why don't I draw another line? If I connect O to C here, if I can find a way to not erase things. If I connect OC, the OC, if I connect OC, what does that have a length? That is our radius as well, right? Radius of our circle, R, so that's equal to OC. Well, one last thing, if we have EO, we don't know what that length is, and kind of hopefully see where I'm going with the triangle here. Let's call that B. So let's go label EO to be equal to B. And from here, I can use the Pythagorean theorem with triangle OCE. So we have triangle OCE, and we're gonna use the Pythagorean theorem here. A squared plus AB squared is equal to an R squared instead of our C squared. So we have a right triangle, we use the Pythagorean theorem, A squared plus B squared equals an R squared. This is our first formula that we're gonna be using here, number one. And we're gonna be using some more formulas maybe to, we're gonna come up with some other ones and we're gonna do some substitution in a second. What do we know about side length EF? That side length has the same length as DA, which is equal to 2A, right? There's a rectangle, probably the rectangle says same side length, which is equal to 2A, which EF is also equal to an R plus a B. Right there. So now we have another equation, 2A equals R plus a B. Let's get B by itself here. So B is equal to a 2A minus an R. And that will be our second equation right there. All right, we have two equations. I'm going to take the first equation, a squared plus instead of b, I'm going to put this 2a minus an r in. 2a minus an r squared equals an r squared. And I'm going to see if I can get this equation to really get r by itself. And you'll see why in a second, or how. So we have a squared here. That's a 2. We went up top above the a squared, plus squaring out 2a minus r gives us a 4a minus a 4r plus an r squared is equal to r squared. Luckily for us, the r squareds cancel. A squared plus a 4a gives me a 5a. We add a 4r to both sides, and 5a equals a positive 4r. And if I want to get r by itself first, I'm going to divide both sides by 4. But you can always get a by itself too, for this, to be honest. And r, in terms of r, or r in terms of a, would be a 5a over 4. So now we have the radius in terms of, well, ways of the side lengths of our square. Let's go compare the two. A square here, we said, is the area, a perimeter of the square, sorry, the perimeter of the square. So doing, not the area, the perimeter here. The perimeter is, we're adding up all the side lengths. So we have 2a as a side length, and we have 4 of them. And so our perimeter in terms of a would be a 8a. So perimeter units. So the perimeter square is 8a. Now we have r in terms of a, so we want to find the circumference of the circle, which is circumference equals a 2 pi r. But now we have r in terms of a here, so circumference equals 2 pi times r, 5a over 4. From there, we will kind of want to simplify. I'd say, well, this kind of cancels, we get 2. So really our circumference is a 5/2 pi times an a, and a, or pi here, if we approximate pi, our circumference of the circle comes out to be about, right, we approximate using pi, and we have a 7.854a. So if the perimeter is 8a units, and our circumference is 7.854 approximately times a units, we kind of can not really worry about the a there, and we know that the square has the larger perimeter because 8a is larger than 7.854a. Well, hopefully you learned something here on really which one has the largest perimeter, and if you did, make sure you like this video and subscribe to our YouTube channel. This helps us make more of these fun math videos for you and for everyone else. So, as always here, thanks for watching.